Hello and welcome to a webinar hosted by Oilfield Technology with Tracerco. I'm Elizabeth Corner, Senior Editor of Oilfield Technology, and thank you everyone for joining us. Today's session is From Injection to Insight, Tracer Use in Surfactant Huff and Puff Projects. We're going to explore how Tracer technology is transforming surfactant-assisted Huff and Puff operations. We'll learn how tracers are used to monitor fluid movement, to evaluate sweep efficiency, and to optimize chemical performance in unconventional reservoirs. We're going to begin proceedings with a presentation and then follow this up with a Q&A session with questions from the audience. And your presenters from Tracerco today are Claudio Ramos, Senior Technical Consultant, and Richard Abaud, Technical Consultant. And later on, Mariano Clarisi, Global Technology Manager, will join us for the Q&A. Some housekeeping: if you'd like to submit a question at any point during the presentation or during the Q&A, here is how you do it. If you are joining the webinar on a mobile or a cell phone, you can access the question box by tapping the Q&A icon at the bottom of your screen. And if you are using a desktop or a laptop, click the Q&A icon on the top right of your screen, and then you can ask a question into the box and click Submit. Everyone who registered to attend will receive a recording of the full presentation via email after we have finished today, so you will be able to watch at your leisure. Okay, so before the presentation begins today, we would like to begin with a little bit of audience participation. I'm going to talk you through a few poll questions, the first of which should be popping up on your screen now. If you would answer the question, that would be wonderful. So question 1, how familiar are you with using tracers in Huff and Puff projects? So the answers range from very experienced, I've led or designed tracer programs, some experience, I've been involved in a few projects, heard of it but never directly worked with tracers, or completely new to this topic. Thank you for getting your answers in. We will move on to our second poll now, which should be on your screen. What is your main goal when applying tracers in the surfactant Huff and Puff project? Is it to monitor surfactant placement and distribution? Is it to evaluate sweep efficiency and breakthrough timing? Is it to optimize chemical usage and cost? Is it to troubleshoot underperforming wells? Or is it something else? Thank you. I can see we've got some good responses coming through. Let's move on to poll 3. What is the biggest challenge you face when using tracers in Huff and Puff? Is it budget constraints? Is it interpretation of tracer data? Perhaps it is integration with production data. Option 4 is operational or logistical limitations. Or is it that good one, convincing stakeholders of the value? Thank you for your answers. I think we're ready for question 4. So question 4, how do you currently measure surfactant performance in Huff and Puff? Do you do that primarily with production data, so things like oil rate, water cuts? Do you use tracers and chemical analysis? Perhaps you use simulation and modeling results, or perhaps your answer is we don't currently have a reliable measurement method. Wonderful. And on to our last poll question. I do appreciate you helping us out with this. So the last question, if tracer technology proved to optimize Huff and Puff cycles and reduce costs, how likely would your team be to adopt it? And your answers there range from definitely, we're ready to implement, possibly, we'd need more evidence or case studies, not sure, depends on budget and priorities, or unlikely, not a current focus area. Thank you. We appreciate your input. The polls will remain active in the sidebar to the right of your screen throughout the session today. So if you didn't get a chance to chime in, you can answer them at any point during the presentation or the Q&A. Just click polls. Thank you for listening to me. I will now hand you over to your presenters.
Hello, thank you, Elizabeth, for the introduction, and good morning to all of you joining us online. I appreciate the time and the opportunity to speak to you today about enhance and improve oil recovery techniques, especially the Huff and Puff and the role of surfactants and the use of tracers in these unconventional resources. My name is Claudio Ramos, and I'm alongside Mariano and Richard. And we're representing the Tracer technical team. And I will start us off with a brief overview of these technologies and how they are reshaping the strategies in tide formations. And emphasize the word brief. And then we go next. Okay. So let me start off a little bit talking about the tracer technology. Early on, the industry had relied heavily on the use of radioactive isotopes, and these are effective, but they do pose a safety or environmental concerns or risks. Some companies have banned them altogether, and other ones decided to have high-level management approval in order to use them. So in all practicality, they are banned in a lot of companies and a few countries as well. Tracicles Reservoir Division no longer uses them. Now, in order to perform these evaluations, reservoir evaluations, now chemical tracers were introduced, but they initially had low detectability in the parts per million levels, and this limited their sensibility or resolution. Now, with the advance of analytical chemistry, more modern tracers, these detection units have improved to the levels of parts per billion, and in some cases, parts per trillion. The leap on the detection is due to innovation in the GCMS and other laboratories technologies. Now, this improvement allows us to precisely monitoring the fluid pathways, the fracture conductivity, and the sonar contribution in the complex reservoirs like the tide shell formations. Let me move on now to the Huff and Puff. Early on, originally these were developed for the heavy oil fields, and the Huff and Puff technique utilized the steam injection to reduce the oil viscosity and enhance the recovery of the oil. Now, in unconventional plays these days, the modern use of steam is impractical because they're very low permeability in these formations, and they yield very high or massive thermal losses. So the modern approach is the injection of CO2 as a energizer or energized fluids, the use of surfactant, the use of nanofluids, the use of other chemistries to achieve several goals. The recovery goals, of course, the number that comes to mind, 5 to 8% of the original oil in place is a common factor recovery after an initial fracturing treatment or stimulation. With these enhanced or improved oil recovery techniques, the aim is to go to maybe 15, 20, base case scenario, 30% recovery. And the surfactants are particularly effective in tide formation because they promote the spontaneous indivision and they alter the wearability of the rock by reducing the interfacial tension between the oil and the water and help mobilize the trapped oil. Now that I'm talking about surfactant, let me move on to the next slide. And surfactants, and I recognize that some of you may be very well aware of surfactants and what they are, what they use, but just briefly, surfactants are surface active agents that reduce the interfacial tension between the water and the oil, which facilitates the mobilization of the trapped oil, and improve the displacement efficiency, the displacement of the oil up from the rock into the production stream, of course. The surfactant does this by altering the wettability of the reservoir rock, making it more water wet. The idea is that it releases the oil from the surface of the rock and makes it more water wet, and so the oil can be produced. And as commonly used in the EOR in unconventionals, we have the anionic surfactants, and this is due to mainly to low absorption. Less commonly so are the cationic surfactants. They may react with the clays. These are rich clays formations, so they tend to react a little more with them. Other ones are used in combination with other fluids, nanofluids, other chemistry are the non-ionic surfactants. Whatever the case may be, the surfactant always will depend on the reservoir mineralogy, the reservoir temperature. It'll depend on even the brine chemistry. And some manufacturers specialize in surfactant specifically for formations or for clays. So a surfactant manufacturer may have any specific surfactant for the Midland Basin, one for the Powder River, one for the Williston Basin, and so on. Now that I'm talking a little bit about Huff and Puff, let me introduce a good candidate. What a good candidate for a Huff and Puff project would be. It's a well that is already well producing well, and it has a life of maybe 5 to 10 years already in production. The good question is, should we wait that long? Why should we wait 5 to 10 years? And the question is good because some of the reservoir engineers I spoke to, read about, they mentioned that the original EUR reserves that a good well may achieve that in about a short time as a year and a half to 2 years, recoveries of maybe 50 to 80% of that initial EUR. So these are wells that are way above type curve and they're good producing wells. So waiting 5 to 10 years may be a little long. Another concern about evaluating Huff and Puff is the duration of the sharing period and the resulting loss in production from these good wells. Now, the Huff and Puff itself has 3 phases. The first, the Huff, which is the injection. Here you inject the CO2, the surfactants, other necessary chemistry, and this injection allows for the introduction of tracers as well. Then there is the soaking time, and this is a time where you shut in the well and you allow the fluids to interact with the reservoir. This enables the imbibition and the alteration of the rock variability. And then finally, the puff, which is the production. So you resume in flow or the production, and you monitor those responses. The 2 main or 3 main variables that tracers can help you is the cycle timing and the frequency. Those are and the size of the treatment that you inject. Those are the variables that the tracers can help you improve or optimize. Now, the Huff and Puff cycle uses tracers, and the tracers are essential for the subsurface diagnostics because they help monitor the fluid movement. They may help you quantify a sweeping efficiency or evaluate a chemical performance. They provide insights into the fluid pathways, the fracture conductivity, the zonal contribution, and even interwell communications. Now, the surfactants can be effective placement or subtitration are some of the factors that you will get from a study with tracers, because they inform the soak decision, the cycle frequency, and the wall spacing, utilizing the concentration curves, the breakthrough times, and the decay profiles of uh, these tracer responses to assess the behavior of the reservoir and refine the EOR's strategies. And with that foundation laid for you today, I'm going to hand it over to my colleague, Richard, who will delve deeper into the value of the tracer technologies and walk you through a compelling case study that we have prepared for you today to show you how the tracers can provide actionable insights and help optimize the EOR operation with a real-world scenario. Richard, please.
Thank you for that, Claudio, and thank you all for joining us today. What we're going to go over is a surfactant Huff and Puff. But to start off, why did we trace the Huff and Puff? What was the purpose of the project as far as tracers are concerned? As Claudio mentioned, we're quantifying fluid recovery. We're measuring fluid movement within the reservoir. Right? So we're tracing the injection cycle of each well, and every drop of water going downhole is being traced evenly with tracer. Right? We're monitoring this tracer's movement and this trace fluid movement through the reservoir from well to well. So any number of wells can be monitored. For the project we're covering, it was 12 wells were sampled, but we can sample 15, 20, 100 wells. So the size of a project is really just limited by logistics, obviously, and cost. Multiple injection cycles can be traced uniquely to differentiate performance. So we often go into projects where we're tracing repeat injections over years. So we have a large number of tracers. So each cycle can be traced uniquely and compared one to the next, right? We can even split the tracer across an injection cycle. So if you want to trace the first half of an injection cycle and the second half of an injection cycle and compare the recovery of all the water or gas, we can do that as well, which we do in this following project. The hope for this surfactant study is the injection water recovery is proportional to surfactant effectiveness. If the surfactant is truly changing the wettability of the rock from oil to water wet, oil wet to water wet, you would replace that oil with water, and that water would remain in the reservoir, and the oil recovery would increase, right? We're also, for this project, measuring fluid recovery at surrounding wells. The goal was to keep the injection cycle localized to the injection well, to prevent leak off to other wells or outside the recovery area or recovery range of a producer. You shut those injection offset wells to hold pressure, right? The idea is you want to recover every bit that you pump down. And then trace the first and second half injection just to differentiate the halves. To start off, we trace this job as a continuous injection. So of tracer. So from the first moment of tracer or surfactant injection, we started tracing all the way to the end of injection. Continuous tracer application. And this was over a 6-day period for each well. We can go in and trace a slug of tracer, and that's the typical operation. You go in, you trace a project or a well with a slug of tracer, and you walk away because an injection can take years, and there's a cost associated with continuous application of tracer. When you push down a slug of tracer, it is a great measurement, but it is a snapshot, right? So I'm capturing a small volume of water going downhole and its movement through the reservoir. It's a safe assumption that all fluid going through injection after the tracer is applied is following that same path. So it's a picture, and it's a safe assumption that it's a good picture of everything that's going downhole, unless you change operations, maybe opening and closing wells nearby during or after the injection would change fluid movement, right? So then it becomes a little less accurate. Continuous tracer application through the whole injection cycle. Now you're tracing every drop of fluid that's going downhole or every volume of gas going downhole, right? So now it's much more accurate because even though you change the field subsurface by opening and closing wells or some other means, we are still getting an accurate measurement of all trace fluid recovery. And the next slide. So we're going to go into the actual pump itself. Just a brief overview. We've been running these pumps for years. They are solar powered and they are unmanned. Right? So you're saving on cost versus having us or somebody else out there for a week or 2 weeks or months. It's much less expensive. It is 24/7 operation. These pumps run on solar powered, so they always have juice. They're always running. Right? They are low cost in essence as a pump is concerned. They can trace gas or water injection. We've run these on gas Huff and Puffs, and as you're going to see, a water tracer job. Right? We can overcome a pressure of 5,000 psi, which is fairly high for injection. And our remote monitor dashboard, you can see on the bottom left, we actually not only just track the amount of tracer going down, but the injection rates, the injection pressures, and everything else in between. We can share this with the client as well. Right? This is a TracerCo dashboard for this pump. Now these pumps run rain or shine, snow, storms, we'll strap them down, but they've been tried and true, they've been tested, and these are awesome pumps. All right, let's get into the fun stuff, the actual project. All right, now you have 4 injection wells. So the table on the top left will have the injection well name on the left column. All right, that's well A1 and well A2. Well A1 is the first half of the injection of that well, and well A2 is the second half of the injection. If you take your eyes over to the right, you'll actually see water tracer was applied for that well, all wells. You'll see the unique tracers, and these are TracerCo tracers. The mass of each tracer that was applied, because we are tracking mass recovery. It's not just a concentration. We take that concentration and the production rate and calculate how much of the actual tracer is being recovered in mass. And we compare to what we applied, right? So you can see in that first row, well A1, first half of the injection, 2 kilograms of tracer was spread evenly across that full injection period from January 1st to January 7th. About 20,000 barrels of water was applied. So that 2 kilos was spread across that 20,000. Second half of injection, we just hot swap the tracer, continuing to apply tracer throughout the full cycle. We just swap the tracer out for the second half of the injection cycle, right? And we did that for all 4 wells, A, B, C, and D. Continuous injection, no issues. You can see down the sampled wells below that, obviously the injectors, Huff and Puff, are now producing, so we're sampling those. And then the rest of the wells, obviously remove all identifiers, but wells E through L were offset wells. They were shut in during the injection cycle. All wells are sampled at the same frequency. We're trying to monitor fluid recovery and fluid migration to offset wells. The goal of the study is to ensure that there's no leak off, no fluid is migrating to other wells, therefore you're recovering all oil that the surfactant's hopefully broken loose, right? And we'll go right over to the next slide into the actual data. Okay, so this chart is a concentration curve chart. On the vertical axis on the left, you're going to see concentration. And then on the horizontal axis, the x-axis below, you're going to actually see sample dates times, right? So the far left group of 4, or the left half, is the group of injection wells. Okay? And then the right half, where the red box is, are the offset wells. So right away, you can see that we have low communication. Tracer recovery is primarily at the injection wells. There is some migration to well G. Now, we can't directly compare concentrations well to well. Well A and well B, even though they maybe have similar concentrations, the amount of tracer being recovered is a measurement of concentration and the production rate. Okay, so we won't compare each well's concentrations to each other, but within each well, you can compare the tracer's recovery, right? So this proves They did a great job of isolating the injection to near wellbore on the injection wells. There's low recovery at offsets, and only to well G. I do not have the layout of these wells, so I couldn't tell you exactly where it's going or where that well is. Let's go ahead and focus now on the actual trace wells, because we can see what the data means just by looking at concentrations. Okay, I can see that in well A, I'm producing the tracer applied only to well A. The same for well B, C, and D. Okay. Going to well A, you can see the orange line. It's a higher concentration of measurement for that tracer versus the blue line. The orange is the second cycle. Okay, so now you know, last in, first out. You're recovering more of that second half of injection than you were the first half initially. However, at some point, there's an area of mixing where you're now getting equal parts recovery of both injection cycles. And it was about a month later, you started recovering equal portions of both injection cycles. So that was something interesting to see. So you can also see, and this is happening for every well. So as I say it for well A, you're going to see the same for well B, same for well C. And although well D is a little different, it took a lot longer for that mix or that even recovery, near even recovery. Remember, I didn't mention before, but we have 2 wells with surfactant and 2 wells without. I cannot tell from here the difference, but you will be able to see it in the final result. So we see that the first in is last out, and we see that there is some mixing where you're actually at some point recovering equal portions of both tracer, and you're also seeing that first injection cycle is deposited. It's found as a place to sit near wellbore, because once you open these wells, you'll see well A, the blue line, you're already recovering that first tracer. So it's not moving as a turbulent slug or a solid front and just pushing away and not finding a place to deposit. It is depositing. So that surfactant or that water is finding areas to stop, and it's not just a solid front. So you're recovering the first half of injection at the beginning of the well's production, but you're recovering more of that second half of injection initially. And this goes back to, if you apply a slug, when should you do it? If you apply it early in the injection cycle, you know you're going to recover less of it initially versus later on. This continuous injection of tracer, continuous application of tracer is a great way to measure all fluid and not have any guesses. Well, all right, so we went through the data as far as concentrations are concerned. We see that we were recovering all the tracers applied, all the injection water applied is being recovered. First in, last out, and low communication. That's what we get from these concentrations. If you go to the next slide, we're going to get right into the actual data of percent of recovery. So we see here, and we're going to I'll let y'all look at it for a minute and think about which ones had the surfactant. But well A, cycle 1, we recovered 11% of that tracer. Now, if we've traced that full injection volume, we can see that we've recovered 11% of that first half of fluid. Tracer recovery is directly proportional with the water. Okay. Same thing for well A, second cycle. We've recovered more of that second half of injection. Well, that's expected, right? Last in, first out again. Same for well B. First half, we recovered 8%, second half, 12% of that total volume applied. Well C, you've actually recovered more water. Now you're at 14% of your first half of injection, 22% of the second half of injection. And then well D, similar to well C, 15% of that first half was recovered. 22% of that second half of water was recovered. And you'll see the far right column, I've got the barrels of total water applied, and then the next column over to the left, you'll see barrels recovery. It's simple, 11.4% times that 20,000 barrels equals 2,200 barrels. Right? Now, can you guess which ones had the surfactant? I'm pretty sure you can. Well A and well B had the surfactant. They recovered less of the water. Therefore, we are measuring surfactant effectiveness. It is allowing the water or the oil to break loose, the water to adhere to the rock, and you're recovering less of that water. Now, I can't say that it's not a geology thing or anything else, but this is a key indicator that yes, our surfactant is the surfactant being applied is working. All right. Very little communication, so the offset wells being shut in, mostly zeros down to 0.1% of tracer recovery at offset wells. So the shut-ins worked. The soak time wasn't too long because the client acknowledged to me, they said, we don't want a long soak time because we don't want equilibrium to be reached in this reservoir where this fluid is moving so far from these injection wells that we're not going to be able to recover it back. Right? Keep that surfactant near well bore so that we can get all that water or that oil that is coming loose. One thing I forgot to mention is that concentration decline in the earlier charts. There is previous water in this reservoir, right? So you're not going to recover all the water you applied or all the tracer you applied because untraced water is coming back and diluting this. Okay, on to the next slide. We're going to go through some of the conclusions of the project. It was pretty quick, but it was very, it was pretty simplistic. We're tracing the fluid migration to not just to offset wells, but back to the production well, right? And every bit of tracer, every bit of water applied was traced evenly. Right? Fluid return after injection was measured, and we quantified that as well. Now, the performance was different between wells A, B, and wells C and D. Now, this could be due to well location, changing geologies, and other features. However, we know that wells A and B had the surfactant applied, and wells C and D did not. We recovered a lot more of that water applied to wells C and D versus wells A and B. Now, injection fluid was kept within the desired region of the injection site. No leak off or very little leak off detected. Again, that was a goal. And we measured, and they did a great job of keeping that fluid localized. On average, about 15% of the injection water was recovered. We did stop sampling after a time. Tracer recovery typically becomes exponential in its decline. We did trace the full volume of injection equally with a consistent concentration. Now you might have noticed the concentrations were declining on recovery. That's because the tracer being applied is being diluted by reservoir water or previously applied water, right? So even though we may have traced it at 100 ppb for the entire injection cycle, you would expect to get all that water back with the same amount of tracer at 100 ppb concentration. But once you introduce untraced water, that concentration does decline. We can assume there will be more water recovery after the sample period, but it's going to be low compared to the initial sample period. So it might change it from an average of 15% to an average of 20%, but not much. Right? So we capture the majority of the recovery. The recovery in the first half of the fluids was lower than the second half. Again, it goes back to tracing slugs or not, continuous injection. They did recover a good portion of that first injection cycle. Another goal was how much is too much? How long do we inject until it's unrecoverable? We put too much water in, we're never going to get half of it back or all of it back. So that was the idea of tracing the first half and second half. Did we go too far with the volumes? We concluded it was not. We got a good portion of it. We could trace the first quarter, second quarter, third quarter, last quarter, right? And break it down even more if you want to add a larger volume of surfactant to a project. And with that, we are through the presentation, and we have quite a bit of time to discuss questions.
Fantastic. Thank you so much, Claudio and Richard. Mariano also joins us on screen now, and we can move to the question and answer section of the webinar. If you haven't asked your question yet, now is the perfect time to put it in the question box. So let's start at the top. The first one I can see is about tracer return curves, and it says, how do the tracer return curves differ between surfactant and non-surfactant huff and puff treatments?
How do the concentration curves differ between surfactant and non-surfactant? So we are tracing the carrier fluid, the water, in a surfactant job, right? The curves really don't change much whether it's gas or water. It's really dependent on the mobility of the fluid, right? And gas has higher mobility. But I really couldn't tell you there's a big difference in the curves. It's really, the difference is in the reservoir, the injection cycle, the surrounding wells, and it's just associated with directly traced fluids.
Thank you. And the next question is, what do I need to consider when I'm selecting tracer injection timing in a huff and puff sequence? So what goes into that decision about timing?
Well, the timing is, so you're designing a huff and puff to meet your needs and your goals and objectives, whether it's surfactant or CO2 injection or natural gas. I mean, we've seen it all. It's best to trace the full cycle if possible, right? That's the most accurate measurement. So the timing is just when you start your injection cycle up to the point at which you stop the injection cycle. That's the trace timing or trace portion. Now that is really, that whole project design is dependent on your goals and what you're trying to accomplish.
Okay, next question. Now I can see that Mariano has perhaps already responded to this one on screen, but let's visit it anyway, because I think some others might be wondering about this. The question was, can those tracers be used for biosurfactant, which may be generated in situ in a reservoir?
Yeah, I'll grab that one. The short answer is yes. Obviously, we would need to have a little more detail of the project and where the placement of that biosurfactant would be and what the result is expected, but it's probably through partitioning tracers, or we have a couple of other options. We would need to have a little more information on that. So if that person can reach out to us, obviously we would like to discuss it in detail and give them all the options available.
Absolutely. Okay, so that's one to follow up on. The next one I can see is about, I'm going to paraphrase here. So what can tracers provide that traditional production data can't provide? I hope I've got that one right.
I would need to see that question.
Yeah, let me read. I'm paraphrasing, but it essentially they're asking what kind of insight can tracers provide that traditional production data can't provide?
Yeah. Okay. No, it's a good question. I understand that question. The end goal is making more oil, right? I mean, that's the goal. So if your production is increased, it's a success, right? But how much of a success? I mean, could you get more out of it? So that's the idea of you trace the applied fluid. So we're going into injection cycles, right? To measure that fluid's movement and recovery. Did you isolate it? Did you keep it localized? Well, you trace it to verify that, because the water you're applying might match the water you're already producing at offset wells. If you can't differentiate what you're applying versus what you're producing at other wells, then the only way to measure it is through tracers. Obviously, you've got all kinds of water tests, so your chlorides and everything else, and those are good initial tests and they work, right? That you have some tracer method, but after a while in some mature fields, you can't differentiate what you're putting down versus what you're producing, and isolating fluid movement from well to well, or how much of that fluid have you actually recovered, because you're producing in situ water, previously injected water, or currently injected water, right? You want to be able to differentiate it, you apply a tracer. But you're correct. Oil production is king. I mean, that's what you want. You've got a great oil production, you've got a great well, great project, but could it be improved? That's where the tracers come in.
Okay, on to the
And if I may expand a little bit on that. So one of the variables that we have is soaking time. So one of the questions that production will tell you, yes, it's producing more, it's producing less. But if you vary the soaking time, the shutting time, maybe one well you do a week, another well you do 2 weeks, and you put the tracers, and so the tracers can help you evaluate whether that extra longer soaking time was more effective or less effective. Not that the production wouldn't, but the tracers will help you with that as well. And to a certain extent, the well spacing, know that you can change the well spacing. The wells are already in place, they're already drilled and completed, but is the size of your injection volume optimal? Do you need more? Do you need less? Or you can live with less? Because less injection would mean less chemistry, less surfactant, less of everything, as long as the production is still there. Yes.
Thank you very much. We've got some really good questions in, so thank you if you've been busy asking. Let's get on with the next one. Fabio is asking, did these projects include the application of hydrocarbon phase tracers?
So this project in particular did not. Hydrocarbon phase tracers we typically use during unconventional frac projects to trace the oil in place within each section of a well as you're fracking a well. So not for this project. We have had clients request a hydrocarbon-based tracer for surfactant jobs, but it was prior mixing. We're discussing putting it with surfactant and tracing surfactant directly and not the actual water. So for this project we just traced the water and associated the water recovery to surfactant effectiveness and containment of the injection. But not for this project. We did not use hydrocarbon tracers.
Okay, hope that answered your question. Next one, can the tracers help in distributing the production data in commingled multi-layered reservoirs?
Can you repeat the first part of the question?
I can, yeah. Can the tracers help in distributing the production data in commingled multi-layered reservoirs?
So yeah, that's kind of a broad question, right? So the tracers, this is like, if we're talking interwell, EOR, injection cycle, if we isolate and know where that tracer is going into each layer, then we can compare them directly. And we've done that, and it gets expensive running plugs and isolating and injecting tracer, but we do that often for floods, right? There's also inflow tracers. So we have other products where you're applying or installing a tracer onto the well itself on the screens or whatever, and you use unique tracers per zone, per completed section, and then we can evaluate production from each section of a multi-layer well. But it's kind of a big question, so it's really hard to answer that directly.
Okay. Perhaps then you can get back on that one directly. Let's move on because we've got quite a few coming through. This question says, why did wells treated with the surfactant injection have a significant increase in oil production compared to water injection? How would the surfactant interact in a water with surfactant alternating gas huff and puff?
That's a good question. So we don't have the oil production rates. Okay, unfortunately, we're not privy to that. That would be the operator that would say they had increased oil production or not. So we are just tracking the water, and we're associating water loss to surfactant, the surfactant effectiveness, right? Now we've traced what we call swags, surfactant, water and gas, puff and puffs. I can't speak to the surfactant itself. We are Tracer Co. We're a tracer company. So, and there's so many different surfactants out there. We've hired great people such as Mariano, who has experience in surfactants. But as far as its effectiveness, it's true. As part into oil production, I can't speak to that, unfortunately. But people are doing it. Operators are doing this.
Great, thank you. May I go on to the next question?
Yes.
Yes, okay, so Val is asking, in initial completions, tracers are often used to assess which stages are contributing. What experience do you have with assessing impact of the use of diverters in a bullhead Huff and Puff job?
I've got no experience with
So
diverters in a head Huff and Puff.
in a Huff and Puff, I don't know that we have, and of course, in an initial frac, yes, you can introduce a tracer before the diversion peels or the diversion material is placed, and then one after, and see what is the recovery of those tracers as the well is put on production. On a Huff and Puff diversion, I don't recall having pump diversion in the
Sounds very interesting, though.
Yeah, it could work. If you're having issues with not with the well spacing, but with the interwell communication between the Huff and Puff, and you have a high level of communication between, maybe due to natural fractures, maybe due to the initial fractures from the first completion, then a diversion that would try to break off that fluid injection from the main fractures or highways that are connecting the wells, and more sweeping the reservoir. But a Huff and Puff is usually a method to produce a well itself. So you want to contain it within that well. So you inject in that well, then you want to produce back from that well. But the diverter may help you reach areas of the reservoir that haven't previously been stimulated.
Thank you for that question. Maybe that's the next webinar. That's the topic for that one. Another question here about marginal or late life fields. So can tracers help me justify surfactant use in marginal or late life fields? Anything to say about marginal or late life fields? Shall I repeat that question?
Yes, please.
Yeah. The question was, can tracers help justify surfactant use in marginal or late life fields?
So tracers are a measurement tool, right? We're a piece of the puzzle.
Right.
We don't improve surfactants. We're not directly the surfactant, right? We are measuring success. So we're measuring, in a way, how effective it is. So, or if you're meeting your objectives as containment and everything else. So, tracers are great in any age field. We trace from first injection of a real water flood injection well, right? When they drill it, start applying water, we'll trace it. And then you've got years of measurements down the road as that fluid is moving through the field. It doesn't have to be old or young. Surfactants, as Claudio mentioned earlier, when do you start applying a surfactant? First thing is you want a good well because you don't want to waste the effort and the money on a bad well that's never going to produce well. And then do you wait 10 years or 5 years down the road, or maybe you should go earlier and try it earlier? Those are the questions that are asked. Unfortunately, we don't have those answers. That's not what we're here to do.
But if we go to this same case study that we just presented, there is a way to justify the use of surfactant, measuring the effectiveness of it, because here you produce less water, right, with the use of surfactant. So the two wells that have the surfactant produce less water. If there is a cost associated with disposal of water, or is in fact, once you look at the production data, that he will be open to him. And those 2 wells are more productive. That's how you justify, well, these 2 wells, we use surfactants, we produce more, we produce less water. And so then you can derive an economic output from that. And versus the ones that produce more water and maybe less oil. I'm not sure if it was more oil or less oil, but it all seems to indicate that the ones with the surfactant produce less water. And so that leads me to believe that there was a change in the wettability of the rock, and then there is a more oil production from them.
Thank you, everyone. This one comes from Kjetil, who says, your tracer results alone cannot be a KPI for surfactant effects, as variance in permeability, porosity, reservoir pressure, layers, etc., will affect the flowback results. So Kjetil is asking, do you have this information when you're planning or interpreting those jobs?
That's a very good question, and that's all true. So tracers you have to have a lot of information, and I'm assuming most of you are in oil and gas, and some of you are probably engineers and understand that, hey, tracers are a great tool, but you need to understand everything that could affect the performance of a well. Tracers measured fluid recovery, and the idea was we had 2 with surfactant, 2 without. Fluid recovery was higher. The non-surfactant or water recovery. Now, I mentioned in my comments that it could be geology, it could be well location, it could be landing. A lot of this information is shared between us and the client as needed. A lot of the information we don't get because we are a tracer company. Now, I'm a petroleum engineer. We are a team of engineers, and we will work with customers. We don't have all the answers, but we are providing some key measurements that help them verify that their project was a success. So we do get some information up front for planning. We can apply them to interpretation as if possible, but in the end, it's tracer results on fluid recovery. What affects that recovery is due to many things. It could be the surfactant alone, or it could be other things.
Great, thank you. And actually a follow-up question from Kjetil, if you don't mind, who asks, how do you also control that the outflow and the inflow distribution are the same, which would either be an assumption or a measurement with PLT for more complex wells?
Okay, distribution. So if he's talking, well, I'm not sure. This person is talking about distribution of injection fluid along the lateral. We do not know where it exits the lateral unless they run an inflow or a PLT or an inflow profile as far as its injection site along the lateral well. So there are some assumptions.
Great.
We assume that it's being distributed equally along the injection well, right? And it's being recovered equally along that injection well when it's being produced. So there are complexities, especially with fractured reservoirs. Previously fracture stimulated wells, and you have to draw some assumptions of how that fluid is being displaced, and that's not just us, that's the engineers themselves with working on the projects. Yeah,
absolutely, thank you. Time for a couple more, perhaps. Here's one from Kirk, who is asking, have you confirmed that the presence of back produced injected surfactant does not interfere with the tracer analyses?
Yes, we run tests in our labs and in corporate so we have a fancy lab in the UK where they do a lot of tests, core tests and things of that nature. So we have run tests with surfactants and waters and water tracers and other tracers. So
great.
Yeah, there's no interference.
Okay, hope that answers your question, Kirk. And let's do this as a last question here. How can tracers help me identify early breakthrough or channeling in a Huff and Puff?
Well, that's pretty simple. Early breakthrough or channeling would be tracer recovery quickly. So if you're tracing the full cycle of fluid and that fluid is migrating to another well fast, you're hopefully taking samples, and we plan the sample schedule up ahead, right? You're taking samples early, taking high frequency samples, maybe 1 a day, 2 a day, 3 a day, and you will catch that tracer and that trace fluids recovery at an offset well. And you will see a concentration curve. What you saw in this project here were fairly slow because it was continuous injection. These slow declines in the curves. You will see a spike and a high recovery, and it's a good indicator of, yes, you've got channeling.
Fantastic. I think that's
a quick decline.
Do you carry
So
on?
you see a spike. You see, I'm sorry. I was just saying that you see the spike. You see a fast arrival and then a quick decline.
Yeah.
Fantastic. We will draw things to a close there. Thank you so much, Claudio, Richard, and Mariano, for your input, for answering those questions. And thank you if you did ask your question. They were brilliant today. If we didn't get to your question, we will pass it directly to the TracerCo team for some direct feedback. And perhaps there are some conversations to be had offline as well after today. Please do look out for the full recording of the session, which will be delivered to your inbox in due course. And finally, if you would like to read a regular copy of Oilfield Technology, you can click on the button appearing on your screen right now and register very easily. So thank you again to our presenters from TracerCo. And thank you again, everyone. And goodbye.
Thank you, everyone.
Thank you.